This is the third vodcast for Unit 6. For this vodcast, you definitely want to have a calculator and a periodic table handy. So in the last vodcast, what we covered was a mole is 6.02 times 10 to the 23rd things. Those things can be atoms, they can be molecules, they can be formula units, rainbows, puppy dogs, sheep. Doesn't matter what you're talking about. It's 6.02 times 10 to the 23rd representative particles. The molar mass of water, just to do a little sample calculation here, you've got 2 hydrogens, so you do 2 times 1.01 grams per mole. You have 1 oxygen at 16.00 grams per mole, and you add those together and you get the molar mass of water, which is 18.02 grams per mole. This is exactly the same as saying 1 mole of H2O has a mass of 18.02 grams. Now, the way to work these out is just to do some practice problems. What you want to do is you want to read the problem, figure out what you're looking for, and see what you're given in order to solve the problem. So our question here, how many moles is 5.69 grams of sodium hydroxide? So what I'm looking for is the number of moles. How many moles? What I'm given to solve the problem is 5.69 grams. So what I suggest to students, particularly when you're first learning how to do this, is circle what you're looking for, put a box around what you know. Okay, that way you can always look back at the problem and figure out what you're given and what you're looking for. Eventually these problems are going to become longer, and you know a lot of times with the problems there's a lot of extra information, and so this helps you sort that out. So, first thing you do, you take what you're looking for, and let's just call it X. So you have X moles, okay? It says how many moles in our question. So X moles. And underneath it, you put what is given, 5.69 grams. Now, what we're setting up here are ratios, okay? So we want to have the same exact units on the other side. So since moles is on top on the left, I'm going to put it on top on the right. Since grams is here on the bottom on the left, I'm going to put it on the bottom on the right. Okay? So that's how you're going to set up that part there. Now, in order to fill out the numbers, I have moles and grams. Well, we need to find a relationship between grams and moles. So in order to do this, we need to figure out the molar mass of sodium hydroxide. So if we take our periodic table and we add up sodium hydroxide, sodium's 22.99, oxygen 16.00, you add this all up, and 1.01, you add this all up and you get 40.00 grams per mole. That's the mass of 1 mole of sodium hydroxide. Well, remember, that's the same as saying 1 mole is equal to 40 grams. So next to moles, I would put the 1, and next to grams, I would put the 40 that I figured out. And so it ends up looking like this, 1 mole over 40 grams. Now, at this point, what you're going to do is you're going to cross multiply and solve for X. So we want to get X by itself, and we're going to do that by cross multiplying to get rid of the denominator. And when we write it all out, we have X moles times 40 grams equals 5.69 grams times 1 mole. Now remember, we want X by itself, and in order to do that, we need to divide by 40 grams. If I divide by 40 grams, then those cancel out, and then what remains is my math problem. 5.69 times 1 divided by 40.0 grams. So that's what I want you to do at this point, is multiply these two numbers, divide by the number on the bottom. Okay? And this is what it should show on your calculator. 0.14225 moles of NaOH. Now, we do need to consider significant figures. So we look at the math problem that we did. Here, 5.69 is 3 sig figs. The 40.00, I have trailing zeros with a decimal, is 4 sig figs. Now this 1, this is a counting number, and it's considered to be infinite. So my least number of significant figures in this problem is 3 sig figs. So I'm going to keep these to right here. I'm going to look to the next number to round. It's a 2, so I don't do anything. And there's my final answer. 0.142 moles of sodium hydroxide. Okay. Here's our next problem. Determine the number of moles in 128.14 grams of sulfur dioxide. So remember, you want to circle what you're looking for and put a box around what you know. So in this problem, we are looking for the number of moles, and we're given 128.14 grams of the sulfur dioxide to start. So you take what you're looking for, call it X. We are looking for number of moles, X moles. Underneath it, we put what we're given, 128.14 grams of sulfur dioxide. Now remember, when we're setting up our ratio on the other side, these units go right there, these units go right there. That's how you're going to figure out how to set things up. So yet again, we need a relationship between grams and moles. Well, the mass of 1 mole, if I'm trying to find the mass of 1 mole, I need to add up grams off the periodic table. So I add the sulfur plus the 2 oxygens, and I get 64.07 grams per mole. This is the same as 1 mole is equal to 64.07 grams. So next to moles, I put the 1, next to grams, 64.07. I want you to cross multiply and solve for X. So if you cross multiply, this is the problem, you should get X moles times 64.07 equals 128.14 times 1. We want to isolate X, get it by itself, so that means we need to divide both sides by 64.07. What you do to one side, you have to do to the other. My 64.07 cancels out. And then for my math problem, I just have 128.14 times 1 divided by 64.07. So take a moment, enter that on your calculator. What your calculator should spit out is 2 moles of SO2. Now, we still need to consider significant figures. If I look at this problem, that's 5 sig figs. 64.07 is 4 sig figs, and then yet again, this one is still infinite sig figs. So my lowest number of significant figures is 4 sig figs. So I need to fix this number and make it look like 4 sig figs. So what I can do is I can add a decimal and 3 zeros, and that will give me 4 significant figures. Alright, this example is slightly different. We have to try and set them up the other way. What would 2.34 moles of carbon weigh? Now, when we are weighing something, we are getting the mass. And we measure mass in grams. Okay? So what we're looking for is we're looking for how much the carbon weighs, what the number of grams of carbon is. And what we are given to start with is the 2.34 moles. So I want you to pause and try and set up this problem. Alright, what we're looking for, we are looking for grams of carbon. We put it over what we're given, which is 2.34. Now, slightly different this time. We've got grams. That means over here on top should be grams, and on the bottom should be moles. So that's how I'm going to set that up. You're still going to get the molar mass. Okay, the molar mass of carbon is 12.01 grams per mole. Now, everything right now compares to 1 mole. So it's quite simple at this point. Everything's going to be 1 mole. So you put in 1 for the moles, and then whatever the molar mass is next to grams off the periodic table. Cross multiply and solve for X. When you set this up, you get X grams times x grams times 1 mole of carbon equals 2.34 times 12.01. We want to get x by itself, so 1 divided by 1. This then helps my units cancel out. And you finish solving the problem. 2.34 times 12.01 grams. This is what your calculator spits out. You want to check your significant figures. I've got 3 sig figs. Here's 4. And this one's infinite. So I'm going to round this to 3 sig figs. I get to keep these 3. Look to the next number to round, and it's a 0. So 28.1 grams of carbon is your answer. Now for the next one, I'd really like you to pause if you haven't and try setting it up on your own. It doesn't get any easier. You can watch me do 50 examples, but until you start trying it, you're not going to know what you don't understand. So in this particular problem, we're asked for grams, and we want to know how many grams are in 111.7 moles of iron 3 oxide. So set up what you're looking for. I'm looking for grams of the iron 3 oxide, so there's my X. I'm given an 111.7 moles of the iron 3 oxide to start. The units, okay, again, grams to grams, moles to moles, just like that. Look up the molar mass off the periodic table and calculate it. Moles is always going to be a 1. Grams is going to come off the periodic table. I calculated that to be 159.70. So again, the 1 goes next to moles, 159.70 next to grams. Cross multiply and solve for X. That's your problem. Okay. We want to get X by itself, so we need to set up 1 mole. Our moles cancel, and you get 111.7 times 159.70. This is what it works out to on the calculator. Okay, if we check our sig figs, I've got 4 sig figs here. Here's 5 sig figs, and of course the 1 is infinite. So I'm going to round this to 4 significant figures. So I get to keep these 4. But remember, we want to make sure our answer makes sense. You don't want to round it to 1784. Okay, 1784, that's 1,784. That's not close to 17,000. You have 17,838, and you want to round that to 4 sig figs. So it rounds to 17,840. Now, at the end here, you have a summary. I want you to explain how you would set up a problem to solve for mass or moles. So you don't have to write complete sentences for this part. Okay, you can list steps if that makes it easier. So you might want to start with circle what you're looking for, put a box around what you know, set up your ratio with X. Okay, so take a few minutes, fill this out. I will be checking it. Okay, don't forget your final step at the end about checking for significant figures and making sure your units are filled in.